Can I get a yayer in the house? Yayer. Can't hear you out there. Let's represent the NFL. Nerf Live. All right. So here we go. Right now we're in example 3.2. And I'm sorry, section 3.2, example number 7. And just a few more examples here in this crunchy section here. And basically we're going to be evaluating the natural logarithm function. So now we're going to kind of put a sweet little twist to logarithms, but wow, this is very, 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 very simple. How about your calculator? We're going to use it real quick here. So it says use a calculator to evaluate the function f of x equals ln of x. So we haven't talked about that. I'm going to talk about that right now at each indicated value of x. Okay, so what is up with this whole ln, or I'm sorry, of x and all that? So let me just show you here real quick here. So first of all, we talked about what log is, right? So like say if we had a log, okay, a log of x, and I said, okay, what base is this? Okay, what base is, well, this is base 10, right? And didn't we say, oh, we can rewrite any logarithm in an exponential form, right? So this is the exact same thing as saying 10 to the power of x right here, okay? This is what this means right here. This is this graph, if you were to graph log of x and then graph 10 to the power of x, these would be what we call inverse reciprocal or inverse functions right here. Okay, and so what we're going to do now is this, is that what happens if we have a log that has a base e? Okay, what happens if you have a log with a base e? Well, if you have a log that's a base e, we're going to call this right here ln of x, which the way that we say that is natural log. And if you're like, why don't we put then, you know, NL then? Well, I didn't make that right there. We're going to put ln, but that means natural log, okay? So when we say ln, it's the same thing as saying log base e. It just happens to be, we're just going to rewrite this. Anytime that we have an e as the base, we're going to write it as ln then, okay? And if you want to know what is e, e is this irrational number, and if you look on your graphing calculator, you can just press seconds and then the division sign, and it's going to give you this non-repeating decimal that goes on forever. 71828, and it just keeps on going with, and like it doesn't repeat. We'll talk more about what e is later on, but that's what ln is. ln just basically is a logarithm that just has the base e. So if it says evaluate now ln of x, so if x is 2, so really all they want us to find then right here, we'll go to red here, is find the ln of 2. Okay, and the ln button is, let's see, right below the logarithm. So if you just go to the left-hand side of the calculator where it says log, just go one below that, and it's going to say ln. So ln of 2, all they want you to do in this example is, can you put this in your calculator? That's going to be 0.693. Okay, so go ahead and please do that yourself to make sure that you are placing this into your calculator correctly. ln of 0.3. Go ahead and try that guy right there. And I got negative 1.20, negative 1.20. And this right here is the ln of negative 1, ln of negative 1. And do you get what I get? Which is an error message. Remember how we talked about how we can never take the logarithm that's negative. And let's just remember what this means. This right here means the log base e of negative 1 right here, right? Well, let's see here. E to the power of what is negative 1? See, does it make sense that we can put in any value right here for x that's going to give us a negative? Even if you put a negative number, again, what that does is it just puts it in the denominator. So it's not possible to find an x that's going to give us negative 1. Try any kind of number, a small number, a decimal, a negative, a positive, get negative. So anytime that you take the natural log or the log of a negative number, we say that it's not possible. You're not going to get a real answer. You get an error. Just say that it's not possible right there. And that's just a little thing on natural logarithms. Stop that.